Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 10, Atomic Structure, Part 3. Here are our objectives for today's video. Pause here. So this entire video is just dedicated to quantum numbers. For this video itself, the numbers won't have that much meaning to you. I will try to explain what the meaning is as we go through them, but the goal of this video is just to understand the rules for the numbers. And the reason why I do this way is because when we move on to our next topic, it makes it much easier to visualize where we will be going, but it is normal to feel like there's not a whole lot of meaning when you first learn this topic. So if you're feeling that way during this video, just know it's a completely normal way to feel. Before we get into actually what all of this is, we are going to just first define what an orbital is. It's a mathematical function, so just like y is equal to mx plus b, although more complicated than that, that describes the wave-like behavior of one or two electrons. Another way you can think of it, it is showing where an electron may be. And then quantum numbers just describe orbitals. Pause here. So the first quantum number that there is n. So we talked about this a little bit last video. So that is the energy level for an electron. And so the values of n range from 1 to the row number that the element is in. So let's just say, for example, if I have a hydrogen atom, that can only have n is equal to 1. Whereas lithium could have n is equal to 1 or n is equal to 2, and so on and so forth. Pause here. So the azimuthal quantum number, or L, which I'll typically write in script, that describes the shapes available to the electrons. So you may have heard of the terms S, P, D, F, and we will talk more about what those mean actually in a future video, but they're just showing the different shapes that are available. So, and the values of L range from 0 to n minus 1. So I'm actually going to add on sodium to this as well. So for an electron in a hydrogen atom, L has to be 0. What that means is that there's only s electrons. I'll talk more about that in a future video, so I'm not going to spend too much time on it for the next ones. Whereas for lithium, we have L is equal to 0, L is equal to, or L is equal to 1, which is S or P electrons. Again, more on that later. And then for sodium, I've got 0, 1, or 2, which means I've got SP and D all available. Pause here. Right. The next quantum number is what's called the magnetic quantum number, which describes the specific orbital within the shell. So it ranges from negative L to positive L. So you actually have to know what L is in order to know what the magnetic quantum number is. So let's just say if L is 2, then M sub L, when I say sub, I just mean subscript. So that could range from -2, -1, 0, +1, or +2 are all available. And then you'll actually see, notice how there's 1, 2, 3, 4, 5, that there are 5 possible orbitals within what's called the D subshell. And we're going to see all of this in on the periodic table. Pause here. And then our last quantum number, the spin quantum number, which has nothing to do with actual spinning. It's actually just a historical reason why it is called that. So when I say spin up or spin down, admittedly, that doesn't actually mean anything. It just accounts for the fact that you can only have 2 electrons in every orbital. So each one of these 5 sets of M sub L can actually have up to 2 electrons in there. And this is actually explaining why you have that block of 10 that block of 10 metals in the middle of the periodic table to actually for this reason. I'll show you this when we have class. Okay, I know it's a lot of information to take in at once. So let's take a look at an example because that's really where you learn to apply this information. And actually, we're going to be doing this over the course of 2 problems. That's not just one. Pause here. All right, so let's work through it. So the first one, it says n is equal to 1. Okay, so far so good. Then it says L is equal to 0, which is fine. Then I've got ML is equal to 0, which is fine, and MS is equal to plus 1/2. So that is allowed. The second one, I see n is equal to 2, which is great. And then it says L is equal to 2. This is not allowed because L cannot be equal to 1, or it cannot be equal to n. And then the third one, n is 3, good. L is 1, good. M sub L is minus 1, that's fine. And M sub S is 1/2, that is allowed. Pause here. So the Pauli exclusion principle just states that once you know that every electron within an atom has a unique set of quantum numbers. So no 2 electrons may have the same 4 quantum numbers. So these examples that we had before, where the first and the third were allowed, they're only describing 1 electron each. Every single other electron in that atom has a different set of quantum numbers. Thank you so much for watching and have a great night.